morning, everyone, and welcome to Blueprints for Success, an engineering career panel. Thank you for joining us today. Engineering plays a critical role in shaping the world around us, from the buildings we live in and work in, to the technology we use every day, to the infrastructure that supports our communities. Today we have a group of professionals from different engineering fields who have volunteered their time to share their experiences, career paths, and advice for students who may be considering a future in engineering. Before we begin, I'd like to briefly go over how today's panel will work. I'll start by asking our panelists a few questions about their background, education, careers, and then after that, we'll open the floor for questions from students. So to get started, I'd like each of our panelists to briefly introduce themselves. So just tell us your name, your current role or organization, the type of engineering you practice, and then just kind of a short description of what your company or organization does.
Great. I will start. My name is Casey Walsh. I am currently a program manager at Lockheed Martin. I started my career there. I've been there for 22 years. So I started in systems integration and test engineering. I'm sure I'll talk about that a bunch with the various other questions. I got mechanical engineering degrees, both an undergraduate and graduate degree from UCF a number of years ago. And at Lockheed, we build a lot of stuff. There's 4 different divisions. I work in missiles and fire control. Currently, I'm working on a project that builds the Hellfire missile.
Okay, my name is Stephanie Malecki, and I am an industrial engineer. I also got my degree from UCF. I spent the first 5 years of my career at UPS as an IE, and then I moved to Disney for about 10 to 15 years, and now I own my own consulting company.
Hi, I'm Chance Cavender. I'm a UCF student currently, but I work at Lockheed Martin. I was a manufacturing engineer, and I just moved over to electromechanical engineering. At Lockheed, I worked on the EOTS program, mostly targeting stuff. Yeah.
So just to get started, what would you say first sparked your interest in engineering?
Okay, I guess this is just going to be the pattern. If you guys want to jump in, just let me know. I'll hand the microphone to you. So for me, I have an older brother and sister, 6 and 8 years older than me. They were both engineers. Mechanical engineering for me, when I was young, probably thought about this career when I was in high school. Math and science came kind of easy for me in school, and I found it interesting, much more than like writing papers or, other sciences. And so looking up towards to my older siblings, I was like, I think I want to try to do that too. And then ultimately, originally I didn't want to get in the defense industry. I wanted to work in ride and show engineering, just funny for the Disney people that are on the panel here. And that's what I originally wanted to do. And then, through college and some, for different reasons, that kind of pivoted.
So I actually took a very kind of roundabout path to get to engineering. When I graduated from high school and started college, I was an elementary education major. I wanted to be a teacher. But I had always been pretty good at math and science, but I never really thought that engineering was an option for me. When I was at UCF as an education major, I got a job in the engineering department as a TA for the Intro to Engineering class, and then working in the academic affairs office. So I learned a lot about the different types of engineering. And then finally, it dawned on me pretty quickly that I could do that, and I could make a lot more money doing it for the same amount of time in college than I would as a teacher. So like a true engineer, I ran the numbers, made the decision, and switched my major to industrial engineering, much to the dismay of my father, because by that time, you guys, if you're interested in engineering, you're taking your math and physics classes now, and especially dual enrolled, you guys are accelerating your path. I came in as an education major taking finite math, and so I didn't have any of those prereqs, so it took me a minute to get out with my undergrad, but I was able to leverage the extra time I had in college to get internships and start working full-time while I finished up my last few classes, and then built an amazing career out of it.
Whenever I saw, when I was a kid, I watched, the rocket launches and space shuttle launches, and, that kind of got me into wanting to be, something related to space. At first I was thinking, astrophysics might be cool, but then I realized that's a lot more theoretical stuff and not actually building physical things. And that's what I learned about aerospace engineering, and that's currently what I want to do. So like building planes, rockets, anything that flies, I'm interested in it. I'd like to build something that relates to it. Learning about electromechanical engineering is another thing that got me into it, where it's basically the packaging. So, all the wiring that connects all the circuit boards on like anything that flies, it needs to be able to fit in there and inside of, any housings. I found that to be really interesting at my new position, and it's something I wouldn't have been able to experience if I didn't, try a form of engineering.
I know this question was kind of already. Oh, I know, especially this next question you kind of just answered. But would you say you kind of knew the type of engineering you always wanted to pursue, or did that change over time? And then for students that may be unsure about like what type of engineering they're interested in, what helped you decide? I know we kind of mentioned that for you already.
Yeah, the biggest thing for me was like getting experience, because I started in manufacturing because honestly, when I started, I just wanted a job to get some experience to go on my resume, because any experience is better than no experience. And when I first started out at manufacturing, I realized, hey, this is a lot of writing. I was promised in engineering, I don't do writing, I do math. So I ended up doing that for about 8 months when I finally got to be able to transfer. But it still was a good experience just to see what else is out there. If you end up going to UCF, they have a college work experience program, which is what I'm in. And it's great because you get to experience all these different positions if you'd like. If you like where you're at, you can stay there. If not, you can reach out to other managers, see if they have any openings. It's all dependent on what you want. But yeah, it's a great way to explore.
Yeah, because I worked in the College of Engineering, I was able to be exposed to all different disciplines of engineers and be able to talk to them, learn about what they did. So for me, industrial engineering ended up being the best fit, without a doubt, because I liked the more business side of engineering. I didn't necessarily, no offense guys, I didn't really want to be a mechanical or a computer. That just wasn't it. I don't mind writing. But for industrial engineers, we're really good at making things more efficient. That's what we do. We make them cheaper, safer, faster. And that always really spoke to me. Ever since I was a kid, I like to just make things more efficient. Right now, it's like a process engineer. But I find a lot of fun in that. Like, even if we'll go to a theme park or even like a restaurant, my whole family, because my husband's an industrial engineer as well, and I have 2 little girls, and we'll sit there and we'll like analyze the entire queue, the restaurant delivery, everything, because it's fun for us. We can suck the fun out of any venue for other people, but it's fun for us. And so when I realized that that's really what industrial engineers end up doing, they're able to analyze huge sets of data to make business decisions that are based on that data and drive improvements from the top to bottom of an organization. It's kind of exactly what my brain was wired to do my whole life. I didn't realize it until I knew that industrial engineering was an option.
Yeah, for me, like I said, I thought I would want to I definitely thought that I wanted to build machines, right? Like things that move, things that go. It was really easy for me to conceptualize, a car or an engine or gears or a lever mechanism. So that's what I started out thinking I was going to do as I entered college, and, want to build roller coasters or whatever. But then as things went, and especially as I approached the back half of my engineering school work and into my graduate work, when I started to get involved in electro-optics, so lenses and mirrors, I was like, wow, this is very interesting. And then when I get to Lockheed, I wasn't really doing a lot of mechanical engineering. I was in integration and tests. I was making test equipment with electro-optics and lenses and fixtures and tolerancing on different kinds of things that were at levels I'd never really thought about when you're like, say, build a car or another machine. And so that definitely like pivoted to what I wanted to do. And then once I got in the workforce, very similar to what Chance was saying, like we have like so many engineers, right? Like just the breadth is ridiculous. We have like people that just do analyzing, just do heat transfer. We have stress engineers that their whole career is just analyzing stress. We have a subject matter expert in just component engineering on a circuit card reliability testing. Like, we have an engineer that does like everything, and seeing the real like workforce in a large company like Lockheed, like the door was open to really anything I wanted to do, engineering wise. So, I ended up pivoting more into a management role and stuff, which I will talk about less today because this is more on the STEM side. But there were just so many opportunities that, to explore other types of engineering that I had no idea, because I was like, well, there's a mechanical, an aerospace, computer, a civil. I was like, there's like 5 engineering jobs. No, there's so many. It's crazy.
I know we kind of already brought this up too, but just everyone has a different like journey to becoming an engineer. And I just want to know, like, what would you say your educational journey looked like after high school? Obviously, we still have a student here. And then also, what were your like experiences in college? Whether how did your networking go, internships or research? If you did projects, like how has that shaped your career?
Yeah, that's good. So, we all went to UCF, so we have that in common. But we all have very different tracks. Stephanie talked a little bit about hers. But for me, I started in pretty straightforward, similar to you guys. I was a dual credit student in high school, so I had some college credits in calculus and a few sciences, English, stuff like that. So that let me get a little bit of a head start. As I progressed through, I was just doing core engineering classes. And for me, the thing that kind of changed work experience wise during college, I always had to work in college because I didn't have any, a lot of funding from my folks. So I had a job from 14 to now. I've never not been working. And so through college, I took some different jobs. I got one like building like web pages for the university, worked for the school to get some experience. Eventually, I started with the natural gas company doing 2D like drafting, drawing their where the pipes are on the ground in the street, that kind of stuff. And then when I was a junior, late second semester junior, I get approached by some professors to see if I would be interested in doing some research project and being hired by the university to do this grant, research that was funded by a federal grant for an actual defense program. And so I started working for the university doing research, and that carried me through grad school. They paid for grad school as I worked on that, which was awesome. So I got great experience, and my master's degree in mechanical engineering paid for. And then I started and went out and entered the workforce. So I did an internship. I did not do the CWEP program like Chance did with Lockheed, but generate out all those experiences. And that's kind of how I progressed through to build engineering-based experience through college.
Yeah, so I kind of shared like my route was a little lengthy and a little different, but for me to be able to land the job that I got right out of college was because of internships. And really, like, one of the key phrases for industrial engineers is to begin with the end in mind. Like, it's also very cliche, but I knew that I was in college to get a job. And so when our senior design project came around, the least popular, like, and kids, like, you get in groups and then you would vote on which project you wanted. Well, nobody wanted the UPS early AM delivery analysis project, because we had to be out at the airport between like 3:30 and 4 o'clock in the morning. And it was rough, but I knew that UPS hired tons of industrial engineers. So I talked my group into bidding on that project, and we got it. Before our senior design project was even done, I had landed an internship, worked there for a year. And then even because of the way the prereqs were and everything, and because of my education start into college, I was able, like, my last about year and a half to 2 years, I was only able to take 1 to 2 classes at a time on campus. So it was just finishing the last few things. I had even finished senior design by this point. So I was able to work 40 hours a week for UPS. And then my director at the time told me, he's like, the day you graduate, come in, put your diploma on my desk, and I'll make you an offer. And he did. So I was able to land a job at UPS as an industrial engineer in like 2007, 2008, when the market was terrible. Nobody was getting jobs at the time. Like, it's a rough market out there right now too. But things like that get your foot in the door, get those jobs, started a job on campus because the professors have a lot of contacts in the industry, and can get you even just a meet and greet, a coffee, an email exchange, a LinkedIn link with the people that are sitting behind the desk reading the resumes, and they're hiring the interns and then are hiring the professionals that come in.
As I am still in college, my experience has just mostly been doing projects. If you don't have an internship yet, do as many projects as you can so you have something on your resume. Again, the resume is like your golden key to any internship. You need to have something there that shows that you've done some engineering work on your own, something to show that you know what you're talking about, something to bring up in an interview. I did what's called, they did like a rocket design at UCF where you launch and you get your level 1 certification, as well as they have a bunch of other programs to get certificates like for 3D modeling, all kinds of stuff. So it's very important to get involved in clubs because that's what's going to get you your jobs, your interviews, your internships. That's mostly what gets you those jobs. Other than that, I would say, again, it's just a numbers game to get internships. You're going to apply to like at least 100. You're going to get rejected from 99 of those, and then you're going to get that last one. But again, it's just, you can't let yourself get demoralized from how many you're getting rejected from. You just have to keep applying, and eventually one will say yes.
Yeah. Before you go to the next question, just their comments made me think of something that I want to add. So from my journey, one, Chance is 100% right. So like I joined some clubs in there during college, and that's like on my own time, and I built some stuff, and then we took it to competitions, and then I like had to go to the student government and ask for money to fly us to, Virginia and do this trip. And like that was really powerful for putting on my resume to then have that experience to talk about on a job. So for me, it was ASME, that's American Society of Mechanical Engineers. Depending on what engineering you are, they all have a club. I mean, I think Steph was in SWE a bunch. So Women Engineers, Society of Women Engineers, they do different activities. Definitely do those. And then the other piece that was meaningful that your comments made me think about was the reason I chose UCF or come to Central Florida is there's a lot more industry here. There's jobs here, right? There's internships here versus if I went to Gainesville, right? There's like, it's a small town. There's not as much industry, and I needed a job. So just something else to consider if you're looking at working through college and trying to build that work experience.
So kind of moving away from talking about getting up to our career path, I just want to kind of go into like what you guys actually do. So students will often hear the word engineer, but maybe they have like a broad idea, but they don't really know what the day-to-day work actually looks like. Obviously, this can vary whether you're the only engineer working at a startup or if you're one of many at a big company like Lockheed Martin. But what would you say your typical day looks like in your role?
Yeah, so I'll start with this. So I started with systems integration and test engineering. At least that's what they call us now. Back then, we were just called test engineers. And so my day would, at Lockheed, at all of Lockheed sites now, we work 4/10s. So that's a 10-hour day, 4 days a week. We do not work on Fridays, Saturdays, or Sundays. So we just work 10-hour days on Monday through Thursday. So on those days, it's pretty early. I get up, I get into work. For me, we have flexibility in our hours, but for me, it's usually around 7:30. I work like 7:30 to 5:30. My tasks were mostly building tooling or equipment and test equipment for the systems we built. So Chase mentioned the EOTS, that's the electro-optical targeting system for the F-35 jet. It's in the real basic terms for targeting systems, it's just a big telescope to look at a target to tell a missile where to go or whatever. So when we build something like that, which we manufacture in Orlando, we have to then test it. And so I was tasked with designing, building, this equipment to test the thing after somebody built it. Then we would put it on a table and test it. I did not write the requirements for that equipment. That was another engineer. I did not have to do the quality checks on that. That was a quality engineer. My job was to design it, and then in 3D modeling in CAD, because I was doing mechanical work and fixturing work. Check it, run it through reviews with different other engineering managers, get signed off approvals, and then hand that over to a procurement agency or procurement or manufacturing folks to build it. And then after they built it, come back to me, and I was responsible for putting it down in a room and making sure it all worked and handling any issues that we uncovered when we went and put it together. So my regular day, depending on the phase of the program, was either like all design work, designing the tooling, or integrating the tooling and fixing anything that wasn't quite working right that we needed to make adjustments on. So that's what my normal work day looks like.
So I've had kind of several different jobs throughout my career. So pretty early in my career, when I was at UPS, I would get up, go to work, and because of my industrial engineering background, one of my primary projects was doing time studies. So essentially, I would drive around with the package car driver, so the guys in brown delivering all the packages. And at that time, I'm going to sound old, but that was like really before Google Earth was big. So we literally had to measure the distance from the truck to a front door to the reception desk of a high-rise building downtown, or corporate warehouses, things, so that we could create estimates for how long it was their allowed time. So how long it should take a driver to deliver X number of packages on that route, to come up with standards to be able to say, here's how many stops we can put on your truck, here's how many hours we believe that should take. Because then we collect all those metrics, and then we give that feedback to the managers or the drivers themselves, saying like, you were over allowed, you were under allowed. Generally, if they were under allowed, we would go back out and reassess and see, was it our error or theirs? Because usually they couldn't run faster than what we were doing. Industrial engineers, you kind of do it in a perfect world. How long should it take? And then you add, personal fatigue and delay times on top of that, so that it becomes a more realistic standard. They've got lunch breaks and other things like that, so that is you're not putting 700 packages on a truck and you're telling that guy, hey, sorry, I know you got here at 7 o'clock this morning, but you're not going to be done until midnight. Right? Not fair, but how many is the right number? So that was a lot of what I did at UPS. Then I moved over to Disney, where I actually worked in costuming and entertainment costuming, which when I first, it was actually my husband's first boss who needed an industrial engineer, and called him to call me and said like, hey, would she be interested in this job? I'm like, what would I possibly have to do with costuming? Like, I'm an engineer. I don't really see color like normal people do. I'm not creative or crafty or anything like that. So, but it turned out it was a phenomenal job for me. One of my I had two big projects. One was installing RFID tags into costuming garments, which at the time was very cutting edge. RFID technology was very, very new, and it had never been used in garments. There was ideas to be able to use it for shrink prevention, so like keeping people from stealing stuff. But those tags, we have them in our clothes now, they don't need to be washable, right? Like when you purchase a garment at a store, you cut it out, throw it away, and it's done. At Disney, we needed them to be able to go through industrial washing machines and dryers and clothing presses, very, very hot water, a lot of caustic chemicals, things like that. So working with Fujitsu to develop tags that would, live in that environment, see how many washes they could go through, and then install that in all of our locations, was a really cool project I got to be a part of. And then also my big project was coming up with a forecasting model for deciding like, how many costumes do we need? When do we need them to get here? What is the lead time on them? And when you start thinking through the complexity of that, like at Walt Disney World alone, we had 17 costuming locations. It is the largest working wardrobe in the world. And when you think even just a pair of pants, that pair of pants has a different, probably 8 different waist lengths, 5 or 6 different lengths or waist measurements, 5 or 6 different leg lengths. And there are hundreds of different styles at the Walt Disney Company. Some of those we would share with Disneyland. I supported Cruise Line and then the international parks as well, just trying to seek efficiencies in the millions and millions of garments that we would purchase every single year worldwide. I quickly moved into I was less on the technical side, more in the management side. So I had a team of people. I would say if you do become an engineer, think about what you want your career path to be. Do you want to stay in the technical side as an individual contributor? that's fine, but just know what your strengths are and know what your desire is. For a lot of engineers, that's what they choose to do. That's what lights them up. That's where they find the most passion. It wasn't for me, and I think that's kind of why industrial engineering spoke more to me. I liked the more business side. I liked having a team. I liked being able to influence corporate decisions and business decisions from a data angle and prove that this is the right decision and here is why. And I can save you, $6 million in the next 5 years if we do this, and here's why, and here's how I can prove it. So I always enjoyed more leading the team and doing the more business side than I did the technical design part.
So in my first career as a manufacturing engineer, my day-to-day was usually operators get in there around 5:30, 6 a.m. And as a manufacturing engineer, you're basically if something goes wrong or if there's something wrong with the product, they're going to send it over to you to take a look at it and say, hey, how can we fix this? So I was usually in there around 6 a.m. every day, or Mondays and Wednesdays, because it's a flexible schedule in CWEP. Great program. Love it. But they let me come in, and I would stay there for 10 hours, and most of my day would be spent writing instructions for how to either turn something that's broken into something that's workable, or they would give me projects. I'd work with IEs saying, hey, how can we turn this instruction set into something that can be done faster? Can we make a tool that would, cut down the time? Hey, we're using calipers here. If we had something that was a set height that we could just push into it, it'd be a lot faster. So there's a lot of those projects. But again, just writing instructions for how to fix something that's been broken, or if an operator has a question that they're doing something right according to our instructions, it's a lot of answering those questions. Again, it's mostly just instructions and, hey, did we do this right? Is it actually being built to spec? Looking at drawings. Does this thing still go up to the code? Why did it fail here? What tests do we need to be rerun? Stuff like that. But now in my new position, it's more of, I'm looking at CAD a lot. I'm looking at wiring diagrams, saying, hey, will this actually fit through there? Will the wiring be able to fit? Will it get crimped? Will the wire be damaged if we put it through here? That's what I'm doing now, and I like that a bit more. It's a lot more with the 3D modeling, something I'm more interested in.
I know it's kind of a joke that engineers can tend to be a little more socially awkward people sometimes, and kind of going, obviously that's not entirely true, but kind of with that, how much, I know we kind of brought this up, but especially on the technical side of being an engineer, how much of your work would you say you need to really work as a team versus working independently?
It's mostly, you're going to have individual projects, at least for me, you're going to have individual projects, but you're going to have to come together with a group of others, like I said, meet with IEs, but in manufacturing, you also meet with the quality engineers to see, hey, is this a huge error? Do we need to do some corrective action? Do we need to ship all these parts back out to our supplier and get them fixed? It's mostly, you have your individual projects and then you group up to see, how does this all fit together? Is this a huge problem? What do we need to do to change?
Yeah, I think for me in my career, nobody works in a silo. You have to be able to work well with other people. You also have to be able to sell your idea or your path to the decision makers in the room. And I think being able to influence without authority, so it may be people that they don't work for you, but you need to be able to influence those decisions and explain to them why what you're proposing is the best path forward. So for me as an IE, being able to take extremely complex systems or extremely complicated data and boil it down in a way that anybody in that company can understand, be it the person who this change is actually going to affect on the shop floor, all the way up to the C-suite executives. You have to be able to change your language and modify what you're saying to whatever audience you have in front of you. And I think actually my time at Disney helped me develop that skill or that muscle a lot, because I was a very, very technical person working in a very, very creative environment. And it caused a lot of friction, but without friction, there's no growth, right? So I'll admit, early in my career at Disney, I had some struggle. I could not understand why these people didn't understand what the right path forward was, but they weren't wrong. But to me, I could walk into a Disney park or any theme park, and I really didn't care what people were wearing. So I had to understand that there was still value in what they were doing and providing. And while it may not necessarily drive changes to the bottom line of Disney, there's an intangible value there. When you walk into a Disney park, that the person who checks you in at the front desk has a different costume than the bellhop that has a different costume. When you go to each of the themed lands or the transportation, like it's people notice it, or they may not notice it, but they notice it if it's not there. So my job was working with them to make sure that we could do it and to strike a balance in efficiency and then creativity as well. Like there is value in that. So being able to talk to people effectively across an entire array of disciplines, because when you go into business, not everybody's going to have an engineering degree. You guys are probably used to being the smartest people in the room and the most advanced people in the room. And at some point in your career, particularly if you go to work for like a Lockheed or a Disney or a UPS, you're going to be in there with all the other people who were also always the smartest people in the room. And that can cause a lot of conflict because you're right, but that guy over there also knows he's right. So figuring out a way to work with other people effectively and find those compromises, but also sell your idea and get them to come along with you, why yours is right. But you might also be surprised that they're right a lot of the time.
Stephanie sounds like a manager right there. So I'll start this time. I'll start from my current career, my current path, because I kind of moved into a management role. Throughout I've been there 22 years, and 100% of my job right now is working in a team. And as I go back, everything that they just said is true. The three of us have worked on programs, projects where working with a cross-functional team or a team with different disciplines, different people, a finance person, a contracts person, a mechanical engineer, and an industrial engineer, like to all come to an agreement and with one common goal is the vast majority of engineering jobs. But I will also make note, since it's worth noting, there are some jobs where that is flipped, right? Especially in a larger company like mine. I definitely work with engineers that I didn't do this, but their job is detailed analysis, right? They will come to the team, get a task, they will go back and do a lot of individual contributor work, a ton of analysis on their own. So their job might be, 10 or 20% working with the team, and 80% of their work week is just at the computer, like doing deep dive analysis. So there are those jobs too. But it's never 100-0 the other way, right? They always have to come back to a team, communicate their findings, right? Help other people understand that situation, because they are the super technical expert, and they need a way to communicate that back to non-technical folks where they're not the expert, to why a decision should be made a certain way, like Steph was talking about. So just keep in mind there's a kind of a range in the engineering profession of like how much individual contributor work you are doing and how much teamwork you are doing. And I think that's a great part of this career, if you choose to go into it, is that you can tailor that. As you get more work experiences, you find out what you're good at and what you like to do, because that's the most important thing you can do, no matter what you decide to do for the rest of your life, your career, it has to be something that you enjoy doing, because otherwise you will not perform well, you will be miserable, your company won't be happy, right? It's like a bunch of bad things happen. So you find something that you really enjoy, and everything will be good. And I just wanted to put out there are some places, if you're a more introverted person that's a little less like that, there's jobs like that too that are out there for engineers. So
just kind of working off that same question, just real quick, I only really need one of you guys to answer, but I was just thinking, based off what you guys are saying, when you say that as you look to move up like the career ladder, what do you say that the teamwork you kind of comes up, especially if you want to work and go into managerial, you'd say
Yeah, definitely. Yeah, and Steph worded it in the right way. So even my job currently, and I run a program. I run $600 million a year building Hellfire and Javelin missiles, right, every year. So there's like 500 or 600 people that like work for me, but they don't work for me. They have their own management and their own bosses that hire them and fire them. They support my program. I can't tell them what to do. So, and down at the team level, there's a lot of cross-functional, like, convincing, I'll just use that word, like the other people on the team that this is the way that we should go based on, especially engineers, very data-based, and like our company is very engineering heavy. So, yeah, 100%. You're doing a lot of teaming, and if you're not able to operate in that environment, it will hold you back in your career.
Yeah. I think too, it quickly, if you decide to go into a management position, decide to lead others, those communication and those soft skills become even more important, because when you graduate, you've got the piece of paper that proves you've got the technical background. What differentiates you if you choose to not stay as an individual contributor is your ability to interact with others and influence them and lead them. And it is a complete 180-degree skill set from what engineers generally do and excel at. Because it's not just, part of it is talking to others, but those things like we were saying, join a club when you're in college, that's actually helping you build those skills to move into leadership if you choose. And it's teaching you interpersonal skills and relationships and everything. But also, most of my job, until I started my own company, I worked in very, very large companies. I worked at Disney, I worked at UPS. So corporate culture also plays a lot into the career path and kind of the growth that you get as a leader, the expectations that are put on leaders as you come up in your career and start with, I just had a couple of interns and then ended up having a full team of people that reported to people, and not as big as Casey's, but But now I'm back to essentially to being an individual contributor, but I own my own company. So I work with a lot of, executive, like they're hiring me in to tell them the things that they don't have the people on their staff to do. Like I bring in a very particular skill set that is highly sought in the marketplace. And I've been able to hone that through my leadership skills and everything at my other companies. But engineers absolutely struggle. I mean, the stereotypes are true, right? Engineers struggle with the soft skills, the communication, and we're really, really good at math, we're really, really good at science. And a lot of times we don't spend as much time building that interpersonal communication and soft skills muscle. So the earlier you're able to do that in your career, the more doors will be open for you.
You guys are already answering my next question. I'm kind of going into the skill side. What would you say, like, obviously you guys mentioned it, like just the most important skills for engineers to be successful? And you can talk about the math and the science, but then, again, moving away from that too, just the obvious ones, and then the soft skills, maybe the less obvious stuff.
Yeah, and like I said, like you're going to graduate with a degree in engineering, and that's going to tell whoever is, hiring you that you have those skills. You can do the engineering work. Once you get in the door and start your career, what sets the engineers apart, in my experience, is those interpersonal skills. For me too, I'll be interested in your thought on this. The engineers, even the young ones as interns and everything that have come up, the ability to make a decision. A lot of times because we're so smart and we're so data driven, we get into a complete analysis paralysis. You will never have perfect information to make a decision ever in the real world. You get it a little bit in college, like everything sums to zero, it's perfect, it's pretty. That never, ever, ever happens in the real world. As soon as you make the decision, the business climate has changed. Things are moving so quickly. So the engineers that I've worked with that have been able to excel in their field and move into management and move into like C-suite executive roles have been the ones that can just decide it's good enough. They don't let perfection get in the way of progress. They make the decision and they move on. And it's not always right, but it's at least sometimes right, and it's mostly right. And a lot of times you end up realizing that not making a decision is in itself an action. Doing nothing is a decision. And a lot of times that's a much bigger detriment to whatever you're working on than just having made a decision and moving on.
Yeah. Well, I'm going to jump in because my comments are very related, and then I'll give Chance a shot at this one because he's learning this. I 100% agree with Steph here. I'm where I am in my career as a director at Lockheed because I can make a decision. I'm comfortable with it, and I learned this from one of my professors when I was in college, machine design class. Dr. Hagedorn. He's probably retired now. Crazy old dude. His class was the first class I'd ever been in where he gave us problems. We were designing machines, like I said, linkages and gears or whatever, and he'd give us some parameters and say, you got to make a machine that does this, right? And he'd give us some parameters. We'd learn our tools. We'd apply it. We'd make a big MATLAB worksheet, and then we would turn it in. And then I'd turn to like my coworkers, like peers in the class, like, well, what'd you get as the answer, right? And we all had different numbers. And in that class and with that professor is where I learned that there is no right answer. That was the first time I was ever in like a math or science class where I wasn't like, the answer is 3. No, it's somewhere between like 2.5 and 3.5, and anywhere in there is probably okay. And if you have a 3.5, it comes with this set of bad, situation, and a 2.5 comes with this, and both of them are okay. They are all solutions in that continuum. And once I understood that for the first time, and then I could apply it all the way through my career. But there are still some engineers, right, that I work with even today that don't understand that and try to drive right to the exact answer, and they will spend weeks trying to get there. And being able to develop a skill that is, hey, this is pretty close and it's good enough to make a decision, and go with plan A, that will be a huge skill. And then the other one that I was going to mention, it might come back to me. I'm gonna let you chase that shot. If it comes back to me, I'll bring it up.
I'm gonna jump in really quick. I'll say there's such freedom in being able to make the decision, but also just understanding you don't have to be perfect. Like when you realize that math has progressed to a point where there's not just one answer. On the forecasting side, we would always joke, like, I don't have to be right. Like a forecast is never right. The weatherman is never 100% correct, right? I just have to be able to tell you tomorrow why what I told you today was wrong. That was 90% of my job at Disney. The forecast that we came up with was never completely accurate. Stuff happens. I just needed to have a very intimate understanding of what changed, what was different, and be able to tweak my model to make it more accurate in the future, but it's never perfect. And when you kind of release the ability, the belief that it has to be perfect, that you have to know the single right answer, it is freeing. Like I get to do math and be wrong and still get paid for it. Like it's amazing.
Yeah, it's basically what I've seen is like when I'm designing like tooling to help improve efficiency, I kind of have to make it myself and say, not like go to the engineers and be like, hey, is this good? Does this design work for all of them? It's more of, hey, this is my design. I'm making it right now. I'm going to start designing it now and printing it so that later on I can get more feedback and change it as I go. You can't just be locked down into one answer, one path, because if you keep going down that same path, you're going to find that, hey, this could have been solved 6 months ago if I just went the original way. And like, especially with in manufacturing, it's fast paced with things like supplies. Hey, if we need to do a stock purge because this lot of stuff is bad, that decision needs to be made yesterday. Like we can't have production stopping because hardware is bad. It needs to be made immediately and with some confidence.
Yeah, I do remember the other piece. So why companies hire engineers? It's not just because they can do the math or the science. Through the rigor of an engineering degree, you will learn how to solve problems. You will learn how to take a big, complex problem and break it down into smaller, bite-sized chunks, and then tackle those chunks a piece at a time. And so that skill, like the successful engineers, apply that on everything that they're doing, right? So like I apply that today, even though I'm not in a more non-technical role of taking like big problems, understanding what they are, breaking them down into bite-sized chunks so you're not trying to boil the ocean. And the best engineers that progress through their careers like are very, very good at that. And that problem decomposition into smaller chunks is a real skill.
So we kind of brought up the skills, but a lot of the students here, they're all still in high school, and they're not even sure if they really want to do engineering yet. But what would you say are things that they can do now? Especially we have a former HSCA student here, so he's done very similar stuff to many of you guys have. What are some things that you should suggest that they start doing now if they're looking to go into engineering, or if they're at least interested in it? Whether it be like, I don't know, projects or just courses that they should start taking or thinking about taking, getting accelerated, just stuff like that.
Yeah, projects, clubs, read some books, right? Like fun books. So when I was in high school, my physics teacher had me read a book called The Physics of Star Trek. I was like, why am I reading this? He gave it to me to read over spring break. It was a great book. You should read it. Yeah, I did. And I was like, yeah, I'm such a nerd. But, I read that book and I was like, well, is a transporter like actually physically possible? It was interesting. And it was a well-written book and it was interesting. And then it got my mind going. And that idea, right? So like that one is an example of a book you could read that's kind of like fun, engineering focused. It gets your mind thinking about like, hey, this is some kind of problem, breaking it down. And so things like that, that's what I would say. There's a lot of stuff like that, different kind of books out there that you could read that are pretty interesting and fun. And people that probably don't even watch Star Trek anymore. So I don't, yeah, it's like, yeah, I don't even know that people. But anyway, in Star Trek, they had this transporter and they would move a person from the planet to the ship. And I was like, it turns out that's physically possible. But I didn't know that. And so when I read that book in high school, it kind of got me interested in, a part of engineering and science. So stuff like that. I mean, it seems small, but I would throw that idea out there.
I think that's a really good point. Go after, right now you guys are young. You don't have careers, you don't have families, you don't have all of the other responsibilities. Do the things that are kind of on the fringe of engineering. If a Star Trek book makes you excited.
Whatever.
Casey and I have known each other since college, so we've known each other a long time. We actually met at UCF in engineering. But do the things right now, do the different experiences, read the books, go on the trips, find the things that are kind of on the fringe of engineering to see what you really do. Right now is the time in your life to explore all of the options available to you. Because like what Casey said earlier, find something that lights you up. Find something that you enjoy. And it is the cliche, like find something you love, you'll never work a day in your life. But it's kind of true. Like I absolutely love what I do for a living. It doesn't feel like work to me most of the time. There are days it's stressful, it's hard, there are days when work is work. But for the most part, I just love what I do. It lights me up, it fills my soul. I enjoy it so, so much. And I feel very fortunate to be able to do it and get paid to do it. But each of you are going to you're coming in with a different set of experiences and a different set of interests. So find those things that light you up and see how you can apply an engineering degree or whatever degree, STEM field, whatever you choose into those things that speak to you. But do the internships, do the clubs, like talk to engineers. A lot of it, like you guys just being here today, you've taken the first step. Like you're meeting engineers, you're figuring out what this is about. So you're already on the right path.
Biggest thing for me was, I'm sure if at least one of you wants to be a mechanical or aerospace engineer. Right now, with your Lake-Sumter accounts, you can actually download a student version of like Fusion 360 or SolidWorks, because they have student versions for a lot of engineering softwares like MATLAB, Fusion 360 SolidWorks, Fluid Ansys. Those softwares, if you can get your foot in the door with that, even now just doing like little projects like, hey, I modeled this nose cone for a rocket that I might build, and getting a 3D printer, that was huge. Like I found one on Facebook Marketplace. It was broken for like $20. If you can fix one like that, it's huge, because then whatever you design, you can actually physically print out, make, and hold it. It's pretty impressive to see, hey, I made this on a computer and now I'm holding it, and I can actually do stuff with that. So again, just all those free engineering softwares that you get access to because you're a student, I would take advantage of that. It's going to be very valuable when you get into UCF, like those clubs, like one that I was on, Project Horizon. We wanted a rocket to go up to see the horizon, or the horizon of Earth. We had a high schooler student come in. He was incredible. He had like a ton of certifications in SolidWorks. He had done all these like Air Force drag simulations. He was immediately getting onto our projects, and he was able to immediately help. So if you have any experience with that, like even if it's just like base level, knowing how to like even open it, install it, that's huge. Because there's students who will come up to us and be like, hey, how do I install this? And it's like, okay, we get it. Yes, it's understandable. It can be a bit confusing, but having that drive to learn about it yourself and those softwares is huge.
Yeah, that's actually a really good point. You guys have the opportunity now with those student licenses to be able to explore a lot of software. And just because you didn't take the class in it doesn't mean you can't put it on your resume. Watch the YouTube video, or however kids these days learn. Yeah. Oh, AI is big. Yeah. Teach yourself those things, because you never know when you may start at a company and all of a sudden like, hey, we wanted to implement this XYZ. Have you ever heard of it? You could be like, yes, I have. I may not be proficient, but I know enough about it that I can say, yeah, it might work for us, or I want to learn more about it. And that will put you ahead. But because of those because a lot of these softwares are incredibly expensive. So if you have the opportunity right now to just play around in it. And if you find it something that's exciting to you, keep going deeper. And if it's not, then go find another one. But it's such an opportunity where you guys are right now to be able to do that and have that. It's honestly kind of expected of you. Try all the different things, learn all the different things, figure yourself out, figure out your path.
I like you mentioning the whole like SolidWorks. It's funny. I think their student license costs like $60, and it comes with the certification exams. Like you can take them, include. I think it's cool you brought that up. And kind of going off of that, would you say, how helpful would you say like those certifications are? Are those just kind of entry level things to maybe help you with clubs, or do you think they're not really that helpful?
So you get an internship, pretty much, at least at UCF, nearly every engineering student, mechanical or aerospace, has at least their SolidWorks associate certification. There's a whole bunch of different levels. So there's your associate, professional. There's one for drawing, simulations. There's even an expert one. That one, I think there's only one student in all of UCF, and he's like, I'm getting offers all the time because of how desirable it is. But it's very important that you get at least a certification with it, even if it's just your associate. At UCF, they have a SolidWorks club where they will teach you how to prepare for the exam, and they will even give you a free voucher to take the exam. So instead of having to pay like the $60, it's all free for you if you end up going to UCF.
Which
yeah, that's funny. So I know some high schools now are even like offering career technical programs. So when I was in a freshman and sophomore, my sophomore year, I got my CSWA. I know it doesn't mean a lot, but it's better than nothing. Helps you get introduced to the program at least. I just think it's cool that you brought that up. So kind of moving away from just kind of skills, just on a more personal note, what would you say is the most challenging part? And then what would you say is the most rewarding part of your job?
So the most challenging part of manufacturing was the fact that I wasn't truly interested in it in the beginning. So that was pretty rough for the first few months I was in the program. But as I got through it and got to get more projects and doing other things, because you end up working with other engineers as a CWEP, and you're going to see, hey, my friend's over in like systems and test engineering. That sounds pretty cool. Let me ask if they have an open position over there and see if you can move. So the most challenging part is if you're in a position you don't really like, going and doing that for a while. But it's important that you make that known to your manager so that he knows, hey, maybe I can also help him find a different position or something that he might like better. The most rewarding part for me was moving, because I got to do a lot more. Like, I've only been in my new position for 2 weeks, and I've already gotten to make like 2 or 3 drawing adjustments in their system. So I already have made like an impact. Yeah, like over in manufacturing, I didn't feel like I was doing anything. I was writing instructions for operators to build one thing, and then my work is just gone forever. But here, like my input matters. Like I remember my first day, I had a question. He's like, because I was curious, hey, would I be able to change this? And he's like, I'm gonna leave that up to your engineering opinion. And that really meant a lot to me, because he's like, hey, it's on me to make a decision now. That was huge to me.
For me, I'd say the most challenging part now being, owning my own company as a consultant, is leaning on those skills that engineers don't necessarily have as much, like business development, seeking out new clients. That's really not my strength. So it works well for me to be able to consult with another larger group. But I know one of my weaknesses is being able to put myself out there and say like, yep, I can absolutely do this. Like imposter syndrome is no joke. And I know that I can do it, but I sometimes struggle going into a C-suite boardroom and telling them, here's how I can save you money. Here's what I can do, and really selling that hard. So that's hard for me, particularly being as an independent consultant. When I was working for either UPS or Disney, it was a little bit easier because I knew those people better. They knew me. I had already built that credibility with them. But to do it cold as a sales call, like I am not a good salesperson. That if I was, I wouldn't have gone into engineering. But engineering is where I ended up. So, building that muscle is my most challenging part in my career where it is right now. As far as the most rewarding part, I say there's two. On the professional side, I love being able to improve processes and make companies better, more efficient, functioning more efficiently, safer, cheaper. And I find it incredibly rewarding to go in and say, here's how I'm going to help you, and then deliver on that promise, and often over deliver. It just fills me up. I love what I do for a living. On the personal side, I love what I do because it's given me the flexibility to be able to come in and do things like this. I was able to stay home and be a stay-at-home mom, primarily when my kids were very, very young. They're in 5th and 7th grade now. I don't have to travel a whole lot, but I get to build my own schedule. So I have spent the last probably 20 years now going into elementary schools. I'm very, very passionate about keeping girls and women in particular in STEM. So I go to elementary schools and middle schools and I do science projects. Like I'll roll in with a 10-foot ladder and a bowling ball and we talk about gravity. I'll come in with dry ice and talk about the stages of matter. And it's fun. And getting kids excited about STEM when they're really young is fun. Being able to stay home with my babies has been amazing. And so engineering has given me kind of the best of both worlds. I literally call it my unicorn job because I get to do both. I get to be a professional and exercise my brain and do the things that I worked so hard on my engineering degree for. But then when my daughter's robotics team didn't have a coach, I was able to step in and coach robotics for the last 4 years. And I was able to do that and go 2 days a week after school in the middle of the day. I can come here on a Friday and do the things that are important to me that may not come with a paycheck, but that really they light me up. They fill my soul.
So I'll talk maybe 2 stories from my career. Most challenging stuff really is we have deadlines, right? So early on when I was building some of that tooling and test equipment that I talked about, that was to test a TADS PINVIS system, which is a targeting acquisition and designation site, and the pilot night vision sensor. That's the acronym. We use a lot of acronyms at Lockheed. The TADS PINVIS is the targeting sensor on the Apache helicopter. That's where I spent most of my career when I was doing all my engineering work was on Apache, and a lot of my program management work over the last few years. But I was building this equipment. It was going to go to Japan. Like a ship is showing up on October 12th. Like this equipment has to be done because we can't move it, right? Like it's millions of dollars if we can't get this work done and we have to reroute that shipment. So that comes with some pressures. I don't think it's engineering specific, right? That is just workforce specific that you will have, whatever most people will have at points in their career. And so that means, hey, I got to put in some long hours. I've got to put in some extra effort to go do what we got to get done. And that becomes really challenging, to your personal life. And it also really stresses you out because it's looming deadline is there. But then the reward that comes when you make it there, and like that equipment, we got it done, shipped it to Japan. I spent a month in Tokyo, like installing it and then eating amazing food and experiencing this culture. And it was like awesome. Right. So like that same event that went from like, this is the most stressful thing I've ever done in my career, to this is the best, month I've ever had in my career. Like the next month installing it in this country, we're like great. And then the only the piece for me, like why I work at Lockheed, this is a crazy story, but it really is one of the best things that's ever happened to me. Was nowadays I travel a lot for work. I'm going to different places around the country, mostly in domestic in the U.S. with some international trips. But a few years ago, I was in an airport, and there was a Army personnel, in his uniform, and I sat next to him in the airport. We get to talking, and the normal like chit chat. Like, I thanked him for his service, and it's like, what do you do in the Army? Because I work with the Army because I was working on Apaches, and he, he tells me that he was he's in infantry. He was a ground operator, and we get to talk, and then at some point it comes up that I work on the Apache, and like the script completely flipped. Like, he was thanking me profusely for what I do, because like he literally said, if it wasn't for the Apache, I wouldn't be here right now. And then he told me the story, and when he was in Afghanistan and he was in a bad situation, and they had an Apache come in, and he got out of there alive because of the product that I built. It was like, wow, like just an unbelievable experience that was totally unexpected and just kind of happened in the Atlanta airport. And I was like, this is cool. And it's carried me with motivation through, the rest of my career, and it'll keep me till I retire. It's just like, that's why I love working for the company that I work for, and our particular mission to help bring soldiers home. So that was like a super highlight for me.
So before I kind of open it up just for the student Q&A here, I'm just going to throw a little curveball question. What would you say is one misconception people have about engineers?
I know.
I'd say most of the stereotypes are pretty true.
So I would say that one misconception, it doesn't have to be, right? So like what Steph just said, if you couldn't hear at the microphone, is like, hey, there's stereotypes, and I definitely work with some people that meet those stereotypes. But I'm an engineer. I have a master's degree in engineering, and I work at like a Fortune 50, technology company, and I'm here talking with you guys, and I'm can communicate with other people, and get awesome work done. So like it doesn't have to be that way. And I think Stephanie made a good point, right? It starts with just like practicing, basically. Like everything comes down to practice. The same physics teacher that assigned that, hey, read the physics Star Trek book. Like he never gave homework. And these are some of the things that have really stuck with me. I mean, I was a junior or senior year. And stuff that he said, still resonates with me. So like, we didn't have homework. He's like, I could give you homework, and then it's just work. Like, if you want to get better at something, you got to practice it. He didn't go by Mr. Actually, I don't even remember his last name because we just called him Coach. He's like, I don't want to be called Mr. Smith, right? Like, his title was Coach, because I'm coaching you how to be better students, better, not the same that goes with athletes, right? Like, you don't get better by just like doing work. You get better by practicing. So that message really like stuck with me, all the way through today. And so it comes to like practicing, and some of those stereotypes or whatever, they're easily overcome if you actually work at, practicing, overcoming some of those. And I think like we're kind of living proof of it, because we're, up here and been able to bridge that gap.
I think that's a great point about practicing. Like, find the things as you grow that you need to practice a little bit more. Everybody has an area for improvement. So talk to the people you work with, talk to your family, talk to people who will give you honest feedback, and where are the areas that you have improvement. And sometimes it's hard to sit with that and hear where you have a shortcoming or where you have an opportunity. But the ability to kind of be honest with yourself and then figure out a way to practice that. Sometimes it's whatever that thing is, book for dummies, or it's talking to other people. Find out wherever you've identified somewhere that you want to grow, find somebody that does that thing well and connect with them and just be around them and figure out how they do it, pick up those points. But like, because you guys are all smart. Like, you didn't learn how to do advanced calculus just by reading the book. You had to do problems, right? You have to do the work. As you go through your career, a lot of it is just seat time. It's doing whatever those things are, making the decisions, leading the team, designing the mechanical engineering things. But just do those things and do them consistently and do them well, but always give yourself an internal feedback loop. Where is my area of opportunity? What do I want to work on? Where do I need practice to get to wherever my next step is?
I want to add something to the practicing. Like in my position, if you screw up, no matter what, they're going to be able to fix it. Like, I was so afraid when I was making my first change to a drawing. I'm like, if I change this and I break it, how do I go back? Like, oh, don't worry about it. We can always just change it. And sure enough, I made a mistake, and I'm like, hey, I really screwed up. I deleted like everything. Can we go back to it, please? And it took a bit, but yeah, there is always a solution for some if you screw up. But as long as you are making an effort to try and are actually putting forth effort to change from those mistakes, it's kind of the biggest thing. Because if you just keep doing, it's like in math, if you do a problem over and over again and you keep screwing up the same part, it's not going to help you to keep practicing if on that same part you don't change anything. You need to at least look back at yourself and see, hey, this part I'm doing wrong. I need to just change this. How can I be better at that?
I'd say don't be afraid to screw up either. Don't be afraid to take the risk, make the decision, do the thing, make the change, call the person, whatever. Don't be afraid to screw. You're going to screw up. You will make probably a giant error at some point in your career. Know that it's going to happen. Do everything you can to avoid it. But then it's how you react to that adversity and what you do with that makes the difference between the engineers that are incredibly successful and the ones that aren't. You're gonna mess up. You're going to make the wrong decision. Your leader's gonna come and sit you down and tell you what happened. Or you're gonna have to go to them and say, I really, really screwed up. But come with a path, right? Don't bring me a problem. I always tell my team, don't bring me a problem without a solution. I may not take your solution. We may iterate on it at best and come up with something else. But if you screw up, don't sit on it. Own it. Bring light to it. Tell whoever needs to be involved and work on fixing it. Engineers solve problems. Sometimes you create the problem and you've got to solve it. Sometimes you're solving other people's problems. Just own that and move forward in whatever path is left to you after you've made that error. I think that's also what's served me well throughout my career is things go wrong, or you didn't have all the information, you made the decision, or something changed, or you just made a bad call. It happens. Own it, fix it, move forward. Don't let, also too, I think because a lot of you guys are very, very bright, you're very, very good at what you do. Don't let that become your focus. Don't let that derail all of your future plans because you made this huge, egregious error in judgment or calculation or whatever. Own it, learn from it, put it behind you, move on.
Yeah, so since Steph and I have known each other for a very long time, I'm going to throw this out there. It's not necessarily specifically engineering focused, but just tying in on that, right? You're all about to make some pretty big decisions. They're going to be pretty overwhelming for you. You're going to be like, part of the reason you're here is like, what am I going to do with my life? Where am I going to school? Whatever decision you make, even though it might seem big, it can be changed. See, Stephanie thought she was going to be an elementary education teacher, and now she's sitting here as an industrial engineer, right? And yeah, it came with, okay, I got to go to school a little bit longer, but it was fixable. It was solvable, right? So whatever decision, that you guys are currently thinking about and maybe feeling stressed over or feeling that this is like major life-changing thing, it's not. It is, but it's not, because you can always pivot, you can always learn, you can always grow. Anything you do is going to give you information to be a better person going forward. So just wanted to throw that out there because like this happens all the time with my employees, right? Yesterday I had a guy that works for somebody that works for me. He was in my office and he's like, made a decision, and it didn't go his way, and he was feeling really down about it. And I'm like, look, this is just a job. You made a call. We will adjust and recover from it. It's no problem. It's just a job. Like, your stress level does not need to be that high. And when we talked about like skills earlier to be successful, I think this goes through in all kind of corporate environments and probably most careers, is like being able to not let that stress overwhelm you so you can't perform work is like a true skill. And mid-career is when I started to get that for me. I was like, okay, I can screw up. Like, I started to get comfortable with, like, I can make a mistake and it's okay. We can adjust and I can still get going. And once I worked through that personally, then my work in total, my total work got better and my stress level reduced, and I was happier, and happier employee makes like happier work, or more work and more efficient work. So just decisions can feel big, especially as you guys are making what seem to be big decisions, but know that whatever you decide to go do next, it doesn't have to be like fixed in time forever, right? So yeah.
I'm going to add on it too really quick. You can always change your mind, right? Like right now, you guys are trying probably to decide what college you're going to go to. That seems to be the biggest decision. And it seems right now to you like the whole rest of your life is contingent upon partly that decision, right? What college will you go to? Right? It can be any decision, but don't be afraid to change your mind. Go try it. Do whatever that path is. And then if you do need to alter that decision, don't beat yourself up. Because now you got a whole bunch of extra data. You can now make an even better decision because you've progressed in time that much further. You have additional inputs. You have better information to make a new and different decision. Don't necessarily always think of it like you made the wrong decision back there. No, you made the right decision with the information that you had in the past. Now you have new and better information to make a different decision, or keep making the same decision, but keep that continuous feedback loop of where do you want to go? What are you trying to do? Do you want to keep doing what you're doing?
The changing, like being able to change your mind and doing what you want to do, I would highly recommend learning how to advocate for yourself, because you may have someone who's telling you, hey, I need you to do this, or he's like I had a coworker in my job who at Lockheed, there's like levels of engineering. He pretty much had a level 2 engineering like promotion held over his head for the better part of like 6 months to a year. And eventually he kept advocating for himself, and the manager wasn't really doing much. So he moved. You can always change your mind to go somewhere else, to find somewhere better if you feel like you're not changing, or if you're not going the direction you want to go in.
Yeah. Don't be afraid to ask.
So at this point, I try to answer a few good general questions here. But I just want to open the floor up for some students. If you just want to raise your hand. Again, don't be scared to get specific. I know we have 2 Lockheed engineers here, and I know some people in the audience that specifically are interested in Lockheed. So just don't be scared to ask some specific questions or more general questions. Just raise your hand, and they're here to answer and happy to answer if you have any.
Do we need a microphone with them, or you're just going to be loud enough? It's a pretty small room, I think.
I don't know.
So I was getting in, I'm taking currently right now an industrial safety course, and I was gonna ask you, what are you guys' thoughts on that? Because I get I believe, I forgot the certification name, but I thought it right now, but I do get a certification for industrial safety. So what are you guys' thoughts on that?
Yeah, so not an area of my expertise for that, but we have, like at Lockheed's a big company. We have sites like I don't know, every state, probably a zillion countries or something. And each one of those will have an organization around our industrial safety. They're in our facilities, what we call facilities organization at Missiles and Fire Control at Lockheed. And so that is that group does that piece on evaluating and checking all the blocks, because we have, I don't know what safety is, part of VASH, But we are quality certified, like ISO 9001 and 14,000 and stuff, and there's all these requirements in there that have to be met that these organizations like help us meet. And then that group also does, like for us, our civil engineering work, I guess I would say. Like we don't do a ton of it, but we like build buildings, like or expand buildings or lay out roadways like on our property. And that same group is doing that. So I don't know much about those certifications, but like there are career paths in that for like at companies like mine. And that's the type of work they do at Lockheed, at my site.
I would just say in more general, like I can't necessarily speak to that from my experience, but if you're in a class and they're offering you a certification, either at a reduced rate or free, go get it. Get it. If there's a club, a lot of times the club, like when we were in college, like you could get your Six Sigma green belt. You'd go in on Saturdays, the college paid for it. Go get all of those certifications. It's broadening your horizons. You're meeting new people, you're learning new skills. It's a line to put on your resume because you don't know what company in the job posting, they might not have it listed there at all. But in a staff meeting 6 months ago, somebody mentioned that this thing may be something we might want to explore. They see that on your resume and it may get you the interview. And it's also showing that you have broadened your horizons. You have a wider field of knowledge than somebody else that their resume is right next to yours on the desk. So do all the things, particularly right now when you can do it for cheap or free. Like do all the things, get all the certifications. If it interests you, don't chase things that you're not interested in, obviously. But if you have some passion around it or think you might, it's a great way to get some expertise.
That's a great question there. Anybody else? If you have another question, yeah. Sure. I'll pass the mic.
I heard you guys say that you went to UCF, and I want to be an aerospace engineer. And I also heard you mention like right now, like one of the biggest decisions is what college I could go to. So I was wondering, I was looking at a program at Embry-Riddle's. I just wanted to see your input, if whether UCF or Embry-Riddle would have the better program to continue with aerospace engineering.
Yeah, Chase will have some thoughts on this too, but to be honest, once you get in the industry and you get your first job, it really doesn't matter where you went to school, right? So it really does not matter. We all are you're gonna end up with the same 4-year, aerospace engineering degree, and that's why I'm like, this might seem like a big decision. It's not as big of a decision as you might think, right? Like I work at like my plant. I'm a director, and I went to UCF. That's like a small school. I've got people that came from Notre Dame and Georgia Tech. I mean, like last night I was at a thing for my guy. He was leaving the company. He was a mechanical engineer, and went to Georgia Tech. And we've got everybody from like we've got people that went to non-technical schools, like doing technical jobs now because they've learned and grown and grew their career with work experience. So both of those schools have excellent engineering programs. They have some differences. A friend of mine that I went to business school with, because after I was done with my engineering work and I started working, I also went and got a business degree at night. And he went to Embry-Riddle, worked for Boeing as an engineer. So both schools are going to get a similar experience from a degree perspective, right? Your college experience is going to be very different, right, between those two schools. And so that's what I would recommend you think about making that decision more. Like, do I care about going to a college football game, right? Like for Steph and I, that was a big decision maker, right? And but for some people, they're like, I don't care about that, and I like would rather be like the big fish in a small pond versus a fish in a bigger pond, or whatever that term is. I'm an engineer, not a English major, but I think the bigger piece is like, hey, what's my total college like experience going to be like, and what is more motivating for me. And I have a son that's at Florida State right now. And I had the same kind of conversations with him, like, do you care about this, and this? And they weren't about the degree or the job after. It was about like, hey, this is where I'm going to spend the next 4+ years of my life. I want to make sure I'm going to enjoy it, just like the job we talked about. So ask yourself those questions rather than like, is this one going to be better to, suited to getting me a job somewhere?
Yeah, I'll actually echo that really quick. So in my career, I worked with engineers from Georgia Tech and from Penn State and Michigan and all over. And we all ended up with that same piece of paper at the end of 4 or however many years that got us in the door. What Casey said about after you've got your first job, it really doesn't matter, could not be more true in my experience as well. So when you're trying to decide, it feels like this huge decision. Where are you going to go to college? Where are you going to spend the next 4 years? It seems pivotal to every other decision you're going to make for the rest of your life. It's not. It matters. Find a college that you're going to enjoy your time, that gives you opportunities where what you think you want to do right now, 100%, it's probably going to change, and it should change. You guys are very young. Right? You got a long time and a lot of growth and a lot of very important growth that's going to happen between now and when you actually start a career. When my senior year of high school, a good friend of ours told me that college is about so much more than the piece of paper that you get at the end. And it is. It's learning about what kind of person you want to be. It's learning how to adult. It's learning so many other things that have absolutely nothing to do with the classes that you're taking, but get you ready for the next phase of your life. And that can happen at any college campus, anywhere really around this world, right? You're going to get out of it what you put into it. And it's so much more of it. It's not about your coursework. If you're getting an engineering degree, for the most part, those degrees, you're going to end up with the same kind of coursework. I will caveat that a little bit to say, particularly like in my degree, and probably any engineering degree, depending on the school you go to, they may have different focuses. So in my industrial engineering degree, because I went to UCF, it was more like service and process focused. If I were to have gotten the same degree at, say, like Michigan or West Virginia, they do more of like a manufacturing style kind of bead on what is essentially the same degree. So for me, I knew I wanted the business side of it. I liked the process side. I liked the people side. So UCF's industrial engineering and management systems degree worked well for what I enjoyed. So there are nuances across the different degrees depending on the school that you go to. Same thing with the kind of opportunities that are offered to you. Like UCF has the CWEP program. There's so many different firms in our area, but like Daytona Beach, there's the same kind of opportunities there. There's no wrong choice for you right now. Don't lose a ton of sleep over it.
Yeah, just before I hand it to Chance, the only other caveat I put on that, because I think Steph and I both are answering this, is because we all like left the educational world and went into industry. I would say that if you are, want to have a career as a college professor and researcher, that decision will make more of a difference, right? So some universities are very research heavy, right? It doesn't matter if you're going to leave there and go work for UPS or Disney or Lockheed, but if you're planning to stay in the university system and be a professor and do research, like my research that I did in grad school, that those professors came and talked to me, and that is their professional career, then you do want to look at the school, probably less so with undergrad, but because in that case, you're going all the way through your doctorate. And then you want to find universities that put a focus on that and get heavier grants and have more research opportunities, because that will position you well to get into a job in that field. And that's probably the only type of work where I'd say, hey, it maybe does matter where you go to your undergrad, so that because you're building working experience that's specific to a job as a college professor. But general industry, everything we said is.
I agree.
Yeah.
The biggest thing for me, because I also was debating whether to go to UCF, UF, or Embry-Riddle, was the cost. Like even with, this is kind of shallow to say, but going to Embry-Riddle, it would have cost me, I would have gone into significantly more debt, whereas UCF, I'm literally getting paid on scholarships to go there. That was a huge thing for me, but also finding what school does more work for you. So like the clubs, seeing what they have there, like the SolidWorks Club, that was a huge reason for me because they offered all these free resources to me, again, for free. Like it was all up to what you wanted to do. There's a whole bunch of different clubs that you can do, like Design, Build, Fly. It's a club where you build a plane and you go and you compete nationally with other schools like Embry-Riddle, and I know UCF, they both have one and they compete. I don't know who won last time, but I hope UCF. But yeah, for me, the big thing was cost, because in the end of it, it's all about what you end up doing with that time. It's what gets put on that resume. If you go to school and you do nothing but go to class, don't do any clubs, your resume is going to be, I hate to admit it, really short, and there's not going to be much on there to convince an employer to choose you over someone else who has a bunch of, projects and other stuff. Like, let's say you went to Florida Polytechnic. They offered me a full ride, but again, they weren't fully noticed yet, and they didn't really have as many clubs that I was interested in because their aerospace degree program was very new. So they didn't really have any projects for me to get involved with. So while price is a big thing, you also have to look at what can they offer me to do during my 4 years, because you can't just do classes because everyone else is also doing classes.
Yeah, I think that's a great point. And I don't be afraid to take finances into the decision about choosing what you're going to do the next 4 years. You are on the cusp of starting your life, and starting that life with $100,000 worth of student loan debt or some other number, it's difficult. I mean, it's difficult. If like what Casey and I said is true, that after you get that first job, the rest of your career path has very, very little to do with the name on the top of that diploma that you got, right? So if I have the same piece of paper and this one cost me $100,000 and this one cost me $5,000 of debt, and 6 months after I walk out, my career path can be the same. Engineers do the math, right? Do the numbers. Do the numbers. It's not just today. It's how are you going to start the trajectory of the rest of your life? Do you want to go buy a house? Do you want to buy a new car? You want to buy an engagement ring, start a family, all of those things. And if you've got tens of thousands of student loan debt, it just changes. It changes every other decision that you make throughout your life. I was very, very fortunate. I graduated without any student debt, so I was very lucky. And I think it's kind of getting more and more common now for people to do that. But you guys are bright. Like, you're gonna get scholarship offers. It's not even that there's no shame. You absolutely should take that as an input in your decision making, matrix when you're choosing a school. They're recruiting you for a reason. They want you to come. They're offering you money to come, and as long as you're getting all the similar degree type, a similar amount of rigor in that degree, and the opportunities, because it's not just about the degree. You really, what you want is a job. If you're staying in academia to do research, it's a little bit different. But you're doing that to start a career, to move on with your life. And part of that, the finances absolutely play into that. Like I said, I moved from an education degree to an engineering degree because I realized, hey, I could do engineering. I can make a lot more money for the same amount of time in college. And it was truly probably one of the best decisions of my life. So don't be afraid to take that as an input.
This is just me being another chauffeur thing at UCF, the whole research thing. If you decide to go to UCF, there's a program called the Excel program where they put a high priority on math. And in your second year, they will, or I believe it's over the summer of your first year there, whatever. Regardless, because you guys are starting off so early, they're going to be, or starting off so far ahead. They have a research program where they'll get you in contact with professors. And usually they don't take students because they don't have the necessary classes. But you guys are starting ahead and you will get more offers. Like, I got a few offers to do research, but it was at the same time that I got the offer to do CWEP program, and I considered industry more valuable at that moment. So I decided to go with the industry choice.
Can I just add on our show? I just want to add one extra thing. I mean, you're only really in undergrad once, and you mentioned UCF and Embry-Riddle. They're very different schools. UCF's a massive school, significantly less tuition-wise. And then Embry-Riddle, some people might want that experience. It's a small school, STEM focused, and to be honest, the campus is really nice. But it's also expensive, so it's beyond the school rankings. I mean, you're only an undergraduate once, so keep that in mind.
I wanted to ask, how did you know that like this would be the job that you wanted to take? Like, I know in the engineering field, there's like the type thing that you can apply to a lot of fields, but how did you know this is what I want to do? I'm satisfied with this. And like, you know that this engineering job is where you want to be for however long you want to be there.
It's mostly just you trying things out, like internships. Like again, the CO program, I found out I did not like manufacturing engineering that much. And so I got to move. So in those 4 years of your engineering, I suggest you take, even if it means delaying your graduation by a semester, take another internship just to try something new that you haven't seen before. Because honestly, that experience is way more valuable than graduating a semester or two early, because everyone's graduating with a degree. Not everyone is graduating with a couple of internships. It's entirely up to you to find those jobs that you're considering and would like to try out.
Yeah, I absolutely agree with that. Don't be afraid to delay you guys are coming in, like your dual enrollment, you're coming in with a lot of credits. You could get done with college very, very quickly. In my experience, I've seen a lot you're not ready to come into the corporate world necessarily all the time. And so the things that you learn in that first job, it can be very, very difficult for kids who have gone through very, very quickly. And you're younger than a lot of your colleagues that are in the same thing. So just keep that kind of in the back of your mind. There's nothing wrong with delaying your graduation a semester or two to get work experience. And B, I would argue that it actually will benefit you significantly over the length of your life and your career. That 1 year-ish quote unquote delay is going to launch you so much further and so much faster because of what the experiences you will be able to have and the things that you can't just learn in a college classroom, corporate culture, interpersonal politics, business, all of that, having a boss, having a job, so many things that you can't even fathom that you don't know until you get into a company and start learning it. So don't shy away from accepting an internship or something that was offered to you because it's going to delay your graduation, because in actuality, it will probably launch your career. Graduation will come.
Yeah, I think I best want to answer your question like, hey, how did you know this was the right job, right? With
That's a good idea.
Yeah. With I didn't know. I straight didn't know. I mean, and look, Chance, he's already switched jobs. He already started with a job and is doing a different job. And you can tell he's really excited about it. He's been doing it for 2 weeks. He can't wipe the smile off of his face, right? So Stephanie started in a whole different career, right? So just coming back to that conversation earlier is just don't be afraid to just make a decision, run with it. You can change the decision. So I started as a individual contributor engineer, and now that I've been 22 years with the company, I don't do that work anymore. Now I'm in management, and I decided a few years into my career that I kind of like to do that, right? So I just wouldn't get too worked up about like, is this the right job, for me? Because once you get into a company and it almost doesn't matter the company size. So like the big company, you can see what other people are doing and like move to a different job of something that gets you, that you're more interested in. If you're in a smaller company, you don't just do one thing. So you're doing like 7 things because you have to, because there's only so much staff. And then out of those 7 things, you get to find out pretty quickly, like, hey, I enjoy doing this more than the other 6. And so I'm going to make that my career. So it kind of it feels like it just kind of happens naturally as you get into the workplace, into these internships, into some work experience. And then you'd be like, okay, now I understand that's what I want to do. I think for the majority of folks, that's how it works, right? So they have an idea, general idea, get in a place. And then once they start really like working, that then is when the picture really comes together on like what I want to do for my career long term. And there's still some people that are still trying to figure it out, even if they've been in the workforce for 10 or 12 years. I regularly talk to folks that are considering leaving engineering and coming into management, and they're like, should I do this? Should I not do this? Like it. And so just that uncertainty that will kind of always be there. And my best advice for you is just to like get started, right? Like get some work experience, get an internship, get in there, talk to people, and don't be afraid that like, hey, I made a decision. It's going to be stuck forever, because you can pivot to a different. I mean, my favorite example from where I work, when I started working there, I stayed through, got my master's degree. So what you mentioned earlier, like we have level grades at Lockheed. College new hires level 1, and then they kind of go up from there. And with a master's degree, you come in at a level 2. So I was like, this young engineer, I'm building these things, I'm designing this stuff. Like I said, I was designing this thing, and then I would give it over to a machine shop, and they would make the tools, because we didn't have 3D printers back then. So we actually had to like cut it out of metal on a 3-axis mill. And there was an operator back there, Damien is his name, and he was a great dude. He was an ex-Marine. He'd been a Marine for a few years, and now he's in our shop. He's a machinist. And he's like, I think I want to do something else with my career. He never left Lockheed, and he went to Afghanistan, and he did some CFSR work, which are like field support guys. He learned the TAD Pinvis, and while he was in Afghanistan in a tent, he like went to college. He got an engineering degree. Like now he's a reliability engineering manager and runs our reliability engineering team. And I see him in a suit and tie at a trade show talking to CEOs, right? And I'm like, this guy was running a machine in a workshop, never left the company, decided I want to do this, and like made it happen. So just stories of different things to kind of give you guys some confidence that seems like a big decision, and it doesn't have to be. Just generally our best advice is just get in there, do some work, and then you'll find your way.
I'll answer your actual question this time. But just make the decision. Pick what you think is lighting you up right now, what your passion is, and go for it. And then learn and test and adjust. That's what engineers do, right? We test and adjust. It may and as you get older in your career, it's probably going to change anyway. You're going to technology is going to advance. There's going to be new and different opportunities that are presented to you. There's no wrong decision right now other than not making a decision. Pick the one that seems like the best right now, and you can always pivot later.
Sure. I can have one more thing. Even if you become like a full-time employee, there will be programs like, I know at Lockheed they have a few programs where you can go from manufacturing to design, or from design to manufacturing. If you want to try that, it's like a year-long trial period, and if you don't like it, you go back to your old position. If you like it more, you can see if the manager will let you stay on. But it's all about being able to trying new things, because you're never locked down to one place. Like once your contract is up, you can go somewhere else. You can try something new as long as you apply for it.
Yeah, let me add that one thing. So I know that our company has this. I think many companies do, but for early career folks too that are specifically looking at this, we have a rotational program, right? For engineers, we call it ELDP, Engineering Leadership Development Program. You have to apply to it. You have to get into it because we can't put everybody in it. But there are programs like in my company, and those are 6-month rotations in 4 totally different jobs. So for 2 years, you do 4 jobs. And at the end of it, the goal is, hey, you should know what you enjoy, and then what you want to go work. So depending on your company, there might be things like that, depending on where you go work too. So just a lot of options. I think folks, generally everyone understands when we hire new employees out of college my goal when they come work at Lockheed is just stay working at Lockheed. Because if you're a good employee and you're doing great work, like we want to retain you and keep you. I don't care what you're doing, because we have like I said, a million different engineering roles, like doing all kinds of different stuff. And if you're a great worker, we want to find you a place that is the work you enjoy, as a general rule of thumb. And I think other companies are operating the same way. So you get in there, figure out what you want to do. You say, hey, I want to do something different. Your managers are going to help you get there. So.
Any other questions? Oh, yeah.
So you guys were like talking about like AI before a little bit. I'm
Yeah, I wanna
pretty
know.
sure a common question that'll be happening in the next few years is like how AI will affect engineering. So AI has had like an exponential growth in the last few years. Do you think it would be like stagnated or something like that? And how do you think it will affect engineers in the next few years, like 2030, something like that?
I'll take a shot at this, and then I'm really curious to see what you guys say about it too, because there's obviously some personal thoughts on that, because none of us can see the future, but I will say a little bit at work. So we work at Lockheed. We have sensitive information, so we have to generate our own AI large language models internally. It's based on I think ours is based on a ChatGPT baseline, but then it becomes offline and we host it on our own servers so that we can put proprietary or company sensitive information in it. I will say that my experience is more dealing with my own son, who's your age. He's just a year or two older than you guys, and when I saw how he utilizes AI to learn and problem solve, it was amazing. And so once engineers grow that skill, they have the opportunity to be significantly more efficient. And so that's why I don't think it's going to stagnate. I think it will continue to develop in ways that are a little more intuitive, or you might end up with like engineering, like focused AI bots, if you will, or programs or algorithms. I think we'll see like large language models. This is where my personal kind of thoughts come in, like come into more precise like engineering tools that will be able to allow for significant acceleration of like design timelines, risk assessments, process roadmaps, analysis. I think AI has so much capability, and we have so many people that still don't really know how to utilize it well. I'm one of them. I'm trying to get better at it, but I'm old. And adopting it is difficult for me. But like today, like in the future, I think that will be like for us growing up. I grew up when I was in high school, when I was your age, I didn't even have a computer, right? Like, period. And so today we like Google something, and in a year or so, like I'm pretty close. Like I'm almost not Googling anything anymore. I'm using AI to find the solution because it's better than the algorithm that Google has to find what I'm really looking for. And that will get better and better and better. And how I think that'll affect engineering is we'll start to see those tools like tailored to solve engineering problems, and the best engineers will know how to use those tools to like differentiate themselves from their peers, because you'll have 10 mechanical engineers working on fixture design for a factory, because we got to build a new product in our factory, for example, and we need all this new tooling, and all of a sudden there's going to be one of those 10 guys that gets his work done in like 2 weeks, and the other guys take 2 months, and be like, well, how did you do that? And they'll be like, well, I'm using these tools, I'm really good at it. I fully expect that to happen in industry over the next decade.
Oh, sorry, could I add on something real quick?
Yeah.
I'm just kind of adding on to the same question. I know you mentioned how it affects, like, and kind of you're mentioning how it affects in a good way. I'm wondering, kind of to add on as you guys answer the same question again, when it comes to, like, for example, majors and careers like computer science have been affected negatively. Do you think that is something that maybe is a concern as well?
Maybe. it's hard to say. I think it's like most technologies, it just pivots, right, to the people that know how to use that. I mean, that's another reason why I'm in the industry that I'm in. We hire a lot of engineers, and it's a particular industry that we can't outsource, right? Like, we're never going to feed top secret or secret classified information into like AI tools. I highly doubt it, where it gets. So there will be aspects of what we do that will probably never get there. So, so I think it just comes down to like efficiency. So folks that write software, we'll still need them to write software, right? We'll still need the same guy to write software. They're just going to be able to write it faster, more efficiently. HR guys, get ready.
I would say it's a tool like any other, and I don't know, 40 years ago, we had tons of drafting tables in companies, and, we had people hand drawing these, and that all went away. And at that time, people couldn't fathom, like, oh my gosh, computers are going to do this, they're going to take over the world. And the best engineers or the best whatever careers can use AI as a tool and make good great. I use it a lot in my job now, and it is phenomenally powerful, almost scary powerful. But I can use it as a tool. I don't think it will ever be the kind of thing where it doesn't need human oversight. It's not perfect. It does need human oversight and input, and it is a tool like any other. It is an incredibly powerful tool, but I don't think it's not going to be the end of engineering or whatever. It is going to force our career paths to evolve. Absolutely embrace it, learn it, test it, train it, because it's here and it's coming in, it's grown exponentially. I don't see that ending anytime soon. Like it's only going to be more and more embedded in every industry. But I think Casey hit it right on. I think it's going to start getting more even targeted in silo specific areas, either healthcare or defense or whatever it is. I think there's going to be, better models for specific. A lot of what we have right now is pretty generic. Like we're very, very much at the beginning of it. But I mean, I've used it all week. It wrote me some phenomenal code that I wouldn't have been able to do on my. No, I'll admit, I would not have been able to do as good of a job as it did. It wasn't perfect. It still took me a significant amount of time to tweak it and test it and get it. But it's a very, very powerful tool, and it's not going away. So learn it, embrace it, and be the one that can help usher it in to whatever it's going to be in the future. Like, I mean, during the tech boom, it was the guys that knew computers and learned that and could usher technology, computer technology into the next, over the next horizon. AI is just that next tool, and there's going to be something else after AI. Like one of these days, you guys are going to be sitting in these chairs 25 years from now, and it's going to be whatever it is. People are like, oh my gosh, it's going to take away all of our jobs. And it happens, right? Like it's creative destruction. In order to advance, some things have to go away. And right now, unfortunately, it's some of like the computer tech people, because AI is able to take that over. Unless you have broadened those horizons and learned all the different things and found a way to either utilize it in your job, implement something different. Like you have to grow too. Nothing is stagnant. Even once you get your first job, you have to continue to grow. AI is just another piece of that.
Yeah, I think especially for like when you mentioned the software engineers, that's going to be kind of a huge thing. But we still will need software engineers when AI can't solve the problem. Because there's always scenarios where it can't. Like at UCF, they have a lot of, they're supposed to be like AI forward, where they put a bit of AI in our classes. Like my aerostructures class, for one of our projects, we had to try and train an AI to solve our problem. And I'm going to tell you now, it took me like over a week to just try and get it to understand how to do, to understand like the 3D space and then how to turn that into an integral. So for at least the next, like, I would say at least 2 years, it's not going to be able to do like these 3D spaces. It certainly struggles with that. So that's where like the engineer comes in, because engineers know how to ask the right questions, and then AI can try its best to, give ideas if, you're stuck. Or if like, let's say you're working on a project and you have a like 30-page requirement, like basically textbook, you could have AI be like, hey, where is this requirement? What does it mean? Can you make sure that I've satisfied it in this project, stuff like that. I feel like they said, it's a very powerful tool, but you just need to know how to ask the right questions.
Any other questions before we close up here? No? Cool. So just to wrap up, just real quick, I don't want to hold you guys too much longer here. Just one quick piece of advice. Like if they left today, weren't here at all, just one piece of advice that you'd say you'd give each individually to students here.
Start applying to internships now and make sure that like your progress is noted. I was able to get my job because someone saw me when I graduated high school, I got to be valedictorian, and someone at Lockheed saw me and reached out to me to tell me to apply to that. So make sure that your accomplishments are known and that you start applying to internships like now.
Don't be afraid to chase whatever it is. You may not know that it's what you want to do or not, but if an opportunity presents itself, keep the sphere of that decision. You own that. You own your destiny. So just chase it. If you're not sure you really want that job, but it doesn't sound like it's really great, chase it. Keep doing the second round interviews, third round interviews. Do whatever they're asking of you. Let you be the one to say no. Don't release that control and let somebody else choose your destiny. Chase it until you decide you don't want to.
I think I'm going to say something like, you're really young, go have fun.
Next.
Right? Like, and we talked about these other things, like doing these clubs or doing this thing, we're making it sound like it's work. And I want to make sure you understand that, like, when I made my little, like, automatic mousetrap fishing pole that I flew to New York and entered a competition with as part of an ASME competition, like, I was having a blast. Like, it was fun, right? Like, making the fix fly or whatever AIA, the aerospace engineering thing, where you go make a plane in a lab with some other college, kids, peers of yours when you get into college. Like, it's fun. Like, it's fun. So, a bunch of stuff we've talked about today, like advice about doing stuff here, or get this internship, or, do this club or whatever. It all needs to be rooted in, like, I'm doing that because it's really fun. Like, when I made my human powered vehicle bike, right? Like, for another ASME project, that was a mechanical engineering club. Like, it was a blast, even though I got a scar here because I crashed it. But, like, we went up to Virginia Tech and I met these other, college kids, and, like, we just had, like, so much fun with it. And so just don't forget that piece, right? Like, you're young, you're about to go off to find a college, go off there, make new relationships, find some of these clubs, do some stuff, and have fun with it. Because if you're really enjoying it, that's going to really be what carries you through to get an internship, get a job, because you'll be sitting in an interview, eventually get to some interviews, and they'll be like, well, tell me about the time you did this. And you'll be like, you'll be excited about telling them the story, right? Like, I've been excited to tell you some of the stories that I have from work today, and you can generate those by, like, doing this stuff when you're in school. So, go have fun, and don't worry, don't sweat the small stuff, or what seems like big stuff is really small stuff, and know that you can always pivot and change. But make sure you, over the next, like, 4 years, that you're really finding some stuff that, like, makes you happy and you have fun doing it. And if they're tied into those things, they'll carry through, and they'll carry you through resume and internships and interviews, and you'll get to a workplace, and then if you do things right, you'll continue to have fun that way, for the rest of your career. So.
Yeah, so I'm actually going to echo that, because you guys are all coming into college with so many credits. Don't feel like you have to rush it. You have the whole rest of your life to work, right? Like, have fun in college. Casey and I had fun in college, right? And, like, now we still see each other. I see him all of football season because we have UCF season football tickets. So we go and tailgate and hang out and fun. Like, but that's because of the relationships and friendships. Like, I was friends with his wife first. He actually knew me before I met my husband. Like those are the things that carry you through the rest of your life. Have fun in college. You're going to get the degree at the end. It's the other things that you learn about yourself and people and humanity and life that will really, really set you up for success for the rest of your life. Have fun. You're young. Have fun. Travel.